Hi, in this video we are gonna talk about electrical conductivity in a semiconductor material. Since we know the electron which flow in opposite direction of the current when an electric field is applied, but we don't know how it's actually mechanism. Semiconductor divided into two categories, which is intrinsic and extrinsic semiconductor. Intrinsic semiconductor is the semiconductor which don't have the impurity, while extrinsic semiconductor is the opposite of intrinsic semiconductor. First, let us have a look at how the electrical conduction works in the intrinsic semiconductor. Inside the structure of silicon, each silicon is bonded with 4 silicon by covalent bonding. At temperature of 0 Kelvin, the electrons don't gain any thermal energy to excite themselves, so they won't leave the valence shell. After the electron gain thermal energy at room temperature 300 Kelvin, the electron free from the force of attraction of the silicon nucleus and become free electrons. At this moment, the positively charged holes are produced. When an electric field is applied, this electron will fill the hole in the direction opposite to the electric field and another hole exists. The flow of both electron and hole in the opposite direction generate current. Hence, this process will keep repeated and that's how the electrical conduction works. In industry, the doping process is very important to increase the conductivity of the semiconductor by doping the impurity. Usually, the impurities used in the industry are boron and phosphorus. The N-type impurity phosphorus atom, the donor atom, has one extra valence electron than silicon. If the silicon is doped with phosphorus, the fifth valence electron, which we call donor electron, will be free from the valence shell of phosphorus at room temperature. This won't create any hole. Hence, only the electron concentration is increased when the donor atom concentration increases. This high concentration of electron will contribute more to the electrical conductivity, same as the hole concentration when the semiconductor is doped by boron atom, the p-type impurity. The hole exists since boron has 3 valence electrons. The more the holes, the more electron will fill it in the direction opposite to the electric field, hence more current flow. Hence, electrical conductivity is directly proportional to the concentration of impurity. Let's take the mobility of the charge carrier and the carrier charge as the proportionality constant. The conductivity equation defined as the product of the mobility, charge, and the concentration of the impurity. Since we have the N and P type impurity, hence the general equation will be expressed as follows. As resistivity is reciprocal of conductivity, the graph of resistivity versus the impurity concentration is a decreasing graph, but opposite for the conductivity versus impurity concentration graph. The higher the concentration of charge carrier, the higher the conductivity and the lower the resistivity. In conclusion, the higher the impurity concentration, the higher the conductivity. Thank you for watching.